Here's another example of a infinite series that we can try to apply the integral test on. So we have the sum from 2 to infinity of the ln of n over n cubed. And so the function that's going to go along with that is f of x equals ln of x over x cubed. And this is going to be positive and continuous once we get past 1. Since our series is starting at 2, when we do the integral, that's going to start at 2. So the condition of positive and continuous is going to be fine. The thing that we need to check is we need to make sure that it's decreasing or decreasing eventually. So we'll go ahead and take the derivative of that. So we got low and then d high minus high and d low all over low squared. And we're going to have an x squared to factor out, so factor out an x squared, and 1 minus 3 natural log of x all over x to the 6th. We'll go ahead and reduce, and we have 1 minus 3 ln of x all over x to the 4th. And we're interested in the when the numerator is less than 0. Okay, the denominator is always going to be positive for where we're considering it, so only the numerator is going to change signs. So we're going to go ahead and add 3 ln of x, and then divide by 3, and then the exponential is an increasing function, so we'll take the e of both sides, and we'll have e to the 1/3 is less than x, and this is good enough. Okay, that's going to be good enough. So as long as x is larger than the cube root of e, which is probably 1 point something, that's going to be fine. And it's going to be decreasing the rest of the time. That's what we want. We want it to be decreasing for the rest of the time. If it's got a little part where it's not decreasing at the beginning, that's okay. That's only finitely many terms it's going to link up with in the series anyways, and finitely many terms is not a big deal. All right, so we're going to go ahead and look at the integral. So improper integral 2 to infinity of the ln of x over x cubed dx. And yes, we get to do integration by parts on this. So u is ln x, du is 1 over x dx, dv will be x to the negative 3, and the v will be negative, that should be negative, negative 1 over, I'm going to end up putting this here, so we're integrating it. So there would be a 2 there. I think I end up putting it up there later. So we add 1 to the exponent, it becomes negative 2, and then we divide by the negative 2, so that looks okay. All right, we're gonna find what the antiderivative is right now, and then we'll install it back in and do the improper integral in a minute. Okay, so ultraviolet voodoo doctor. There we go. I fixed my 2 here. Ultraviolet voodoo doctor. So we have UV and then minus V to U, but the V was negative, so those will offset. And so we'll go ahead and rewrite. And so we're going to add 1 to this exponent and then divide by the exponent. So then we'll have another 2 there to make that a negative 1/4. X squared plus constant integration. We do have a greatest common factor of negative 1/4 x squared, so we'll factor that out, and we have 2 natural log of x plus 1 plus your constant integration. So it's good to simplify the antiderivative if we can, especially since we're going to take the limit, and we got to see what we got going on with that. All right, so we're going to look at the limit as b goes to infinity of our antiderivative evaluated at its endpoints, which will be 2 and p. Okay. So we'll go ahead and put that in. So we have limit as b goes to infinity of negative, oops, well I put it as a fraction, okay. Negative 2 ln b minus 1 all over 4b squared, and then evaluated at 2. Okay. Now the form that we got going on here is this is going to be a we got a minus infinity over infinity for this limit here, so we're going to use L'Hopital's rule. So we're going to take the derivative of the top and the bottom and see what we got going on there. So the limit as b goes to infinity, negative 2 over b, and then 8b on the bottom. and we just have that constant there. So the constant really doesn't matter. What we're interested in is this piece. What is this piece doing? If it's converging, then we're good. If it's diverging, then this doesn't matter anyways. Okay. All right, so we'll go ahead and simplify that. That's going to be negative 4 over b plus the constant. And so the negative 4 over b, that's going to go to 0. And so our limit is, we don't really care too much what this limit is, other than it is finite. So if it's finite, then that means that the improper integral converges. So because the improper integral converges by the integral test, that is going to show us that the infinite series is going to converge by the integral test. Okay. So since our improper integral converges, thus by the integral test, the sum n equals 2 to infinity of natural log of n over n cubed, that's going to converge by the integral test.